Let's take a quick look at some common errors of partial derivatives, especially with respect to logarithmic and exponential functions. We are going to need to remember our chain rule, our product rule, our constant rule, and involve those in our derivatives. So when we get started here, we have a function. It's got a variable of x and a variable of y. F of xy tells us that they're both variables in this function. We want to take, for part A, the derivative with respect to x. This is a function that has an x in it. So since it has an x in it, we have to take the derivative of this log function. The derivative of the log function is 1 over what's inside, which is x squared, y cubed, times the derivative of what's inside. And the derivative, sorry, that's a 2. The derivative of what's inside with respect to x, this is a variable, and so its derivative is 2x. The y cubed is a constant because we're working just with the x variable, and so the y cubed comes along for the ride. We are not going to simplify, so do not simplify. Simplify. And so then we're done. For the next one, we are looking at the derivative with respect to y. This is a logarithm with an x and y in it, with that y in it. That's the function of y. We're going to make sure that we keep that x constant for this particular partial derivative. So let's go ahead and get started. Derivative of natural log is 1 over what's inside times the derivative of what's inside. Now we've got the x squared is a constant. It's coming along for the ride. The y cubed is the variable that we're working with here. And so the derivative of y cubed is 3y squared. We are not simplifying, so we leave that as it is. And you get this as your final derivative, just as here. This was your final partial derivative, not simplified. Let's take a look at another one. For this one, we have a logarithm embedded within another logarithm. It is a function that has an x and a y in it, so we can take the partial derivative with respect to x and the partial derivative with respect to y. And it does say here it's a function of both x and y. So let's do part A first, and that's taking the derivative with respect to x. This inner logarithm is what's inside this outer log. So when we take the derivative of this outer log, it's 1 over what's inside. It's what's in the brackets. So it's the natural log of xy. Then we have to chain rule out the derivative of the natural log of xy. Well, the derivative of the natural log of xy is 1 over what's inside, and then chain rule out the derivative of that xy. And since we're taking the derivative with respect to x, the y is a constant, so it comes along for the ride. The derivative of x with respect to x is just 1. You do not have to have that 1 there because it's assumed as being a multiplier. Do not simplify again, and you're left with this function as it is. Let's go ahead and take a look at part B. For this one, we're taking the partial derivative with respect to y. Again, it's a function of x and y. There's a y embedded in here, and so we're going to take the derivative of the outer function and then of that inner function. So let's go ahead and do that. 1 over what's inside the outer natural log, which is the natural log of xy. Then we have to chain rule out the derivative of the natural log of xy. 1 over what's inside, and then chain rule out the derivative of that xy. Now remember, we're taking the derivative with respect to y, so that x is a constant and comes along for the ride. It's like a coefficient of the y, as if it's like a 17. It just comes along. And then the derivative of that y is just 1, and remember, we do not need to write the 1. And so then you're done. This is your partial derivative with respect to y. This is your partial derivative with respect to x. One last look at. We have 4 terms, no logarithms here. We do have an exponential. And this exponential has a base of e. So remember, with a base of, not a base of e, When you do not have a base of e, the derivative of this is the natural log of the base, so it's going to be the natural log of 3. Keep this as it is, then chain rule out the derivative of that exponent. So again, it's going to be the natural log of the base. When the base is not e, it's a number 3, which is an e. So the natural log of 3 times 3 raised to the 2x minus 3y, keep this as it is, and then chain rule out the derivative of that exponent. Let's go ahead now and do that partial derivative with respect to x. So we're going to have the natural log of the base, which is 3. Keep that exponential piece as it is, 3 raised to the 2x minus 3y. Chain rule out the derivative of the exponent. We're taking this with respect to x, so taking the derivative here of 2x, we get 2. And then the derivative, it says minus 3y. That'd be like saying minus 7. It's a constant sitting here, and the derivative of that is 0. So we just get times 2. Move on to the next term. We are taking this with respect to x. This guy is a constant, and so the derivative of that is 0. You don't have to write that, but you can if you would like. I'm going to not. I wrote it. I'm going to get rid of it. And then we are going to take the derivative of the next term, which is minus 2x. We're taking it with respect to x, so the derivative of this guy is minus 2. And then that last term, plus 4xy. It has an x and a y in it. We're taking the derivative with respect to x, so the 4 and the y are constants. So let's bring them along for the ride. And then take the derivative of that x term. And the x term, its derivative is just 1. And so we would have a 1 here, which is the same as 4y. This is that derivative, partial derivative with respect to x, unsimplified. Now let's go ahead and do that partial derivative with respect to y. And we're not going to simplify this one either. So let's take a look. Get rid of this underlining here. It won't do that. That's okay. So we're going to take the derivative with respect to y. This term has a y in it. We're going to do this exact same thing. The only difference is going to be here where we chain rule out the derivative of the exponent. Then we're going to take the derivative with respect to y instead of with respect to x. So let's take a look at that. It's the natural log of 3. Keep the term as it is, 3x minus 3y. Chain rule out the derivative of that exponent. Sorry, there was a 2 there. 2x is a constant. The derivative of a constant is 0. Then take the derivative of that second term, minus 3y. The derivative of minus 3y with respect to y is minus 3. And then we go on to the next term, positive 3y. With respect to y, the derivative is just that coefficient. Move to the next term. Minus 2x here is a constant because we're taking it with respect to y. So that derivative is 0. You do not need to write plus 0 here. You can just keep going to this next term, 4xy. And that one has a y in it. And when we look at that, the 4x is the constant of this term with respect to y. And then we have to take the derivative of the y. So let's go ahead and let the 4x come along for the ride. And then the derivative of the y is just 1, and we don't need to write a 1 here. We can leave this as it is. So this is the derivative with respect to x, partial derivative. This is the partial derivative with respect to y. So that's it. Those are the major issues that folks are having right now with partial derivatives, with exponential and logarithmic functions. If I can add just thinking ahead, that we do have a function that has x's and y's in it, but what if we have a 3e raised to the, let's make it 2x minus 3y. Let's put a square on that just for fun. And let's find the partial derivative with respect to x. The 3 out front comes along for the ride. The e term gets rewritten exactly like it is, and then we multiply that by the derivative of the exponent. Now remember, the derivative of the exponent is respect to x, so the derivative of 2x with respect to x is 2. And then you take a look at minus 3y squared. Well, there's no x there. And so this is a constant as if it was 17, and the derivative of a constant is 0, so that would be plus 0. So we are left with this. If you have to simplify this, you just multiply the 2 times the 3 to get 6, and the exponential portion comes along for the ride. We can go ahead and do this with respect to y. So the partial derivative with respect to y, the 3 comes along for the ride again. The exponential gets written exactly as it is. There's a minus sign here. And then times the derivative of that exponent. The derivative of the exponent with respect to y, this term is a constant, so the derivative is 0. We're not going to write anything. Then minus 3y squared. What's the derivative of that? Minus 3 times 2 is minus 6. Y to the 2 minus 1 is 1. And you are done. You can rewrite this one as well. 6 times 3, negative 6 times 3, negative 18y. And then the exponential e to the 2x minus 3y squared. There you go. So there's one with a base e as well, just so that you can remind yourselves of the difference between base e and base 3. So that's it. Hope you're having a great day.